How's it going? Hope everyone had a good time last class learning a little bit about the coronavirus and some of the good impacts of the coronavirus. So we've heard a lot about that. We also hear a lot about hand washing. So I thought it was a good idea today to take some time to learn a little bit about soap, how soap works, and why it's effective in trying to prevent the spread and transmission of the coronavirus. So we all know what happens when you mix oil and water, but for the sake of an experiment, we can do it together anyway. So I have some vegetable oil that I pour into a jar. And I'll put the other half, so roughly half. And I'll put a little bit of water in the other half. All right. So I've got my vegetable oil and my water. That's not the lid. Mix here together, right? We can all see the vegetable oil on top, the water on the bottom. Water has a density of roughly 1. So that means the oil's got to be a little bit less dense for the most part, which is why it stays on top. If I shake this up, what do we expect to happen? We should theoretically have it all mixed together and then take a little time to separate. So we're going to do that, and then we'll talk about soap, and then we'll come back to it. So if I shake it up, we get a nice mix. It looks pretty uniform, but we're going to let it settle out and then see what happens. So I'm going to put that aside for right now. So let's talk about soap. Soap is made of a few different molecules. Some of them like water, and some of those molecules don't. So we have hydrophilic, which likes water, loves water. Hydrophobic, hates water. Think about a phobia or any phobias that you might have. Phobias are things that you don't like. I have a phobia of mascots or things like big costumes, like if you go to Disney and they have those big costumes. That's a phobia that I have. I hate those things. I don't want to be near them. So hydrophobia means fears water. So when we have soap, I said we have some particles that love water and some particles that hate water. I have oil and water. Oil would be a hydrophobic substance. It fears water. It doesn't mix well with water. So we have the oil and water structure. So I said soap has parts that are hydrophilic and hydrophobic. So we have the hydrophilic heads of soap. So hydrophilic, again, likes water. And all of those little hydrophilic particles, they all have these like little inside areas that are hydrophobic. So the insides are phobic, and those outsides are philic. So if there's water all around, such as when you're washing your hands, there's water all around. You have dirt, you have grease, you have grime, you have oils on your hands. You wash your hands. If you don't use any soap, you're going to wash your hands for a couple seconds, and the oils, grease still going to be on your hands. You need to use soap in order to make it clean. Because when you're using the soap, the hydrophobic areas are able to break apart the outside area. So I'll put oil in the middle, because we have oil, grease, whatever it is on your hands can be broken off. So it's breaking off those little bits and pieces and creating droplets. And then those droplets can actually be washed off by the water. It also takes a little bit of time. It takes more than a couple seconds. It takes about 20 seconds of full hand washing to really get those, to really get your hands clean. So what does this have to do with viruses? I'm talking about oils and grease. Viruses have a sort of fatty and protein membrane on the outside. So that fatty area acts kind of like the way that the oil acts. So that the soap can actually break apart the membrane on the viruses and then wash the rest of it away. It kind of breaks it apart, falls like a house of cards. Those viruses can be washed right off your hands. So what we're going to do with our little demo here, and as predicted, the oil and the water basically both were able to separate. There's a little bit more bubbles in the oil now, but that's just because it was shaken. So if I take a little bit of hand soap, and so right here we have the water, hydrophilic. We've got the oil, which is hydrophobic. The soap, hand soap that we're going to put in here, like I said, has parts that are hydrophilic and parts that are hydrophobic. So if I'm able to put a little bit of soap in there and shake it up, this time, instead of the substance being able to separate back to the way it was, it won't be able to separate. It's going to stay kind of suspended like this because of the way that the soap is kind of hanging onto it. It has separated all those oil molecules and kept it suspended together in with the water. So your job today is to do a little bit of research on soap, how it works, and the history of soap. People didn't always wash their hands. People didn't always bathe and shower. That's kind of a new thing within the last couple hundred years. Doctors would actually do surgeries without washing their hands. And they said a true gentleman has clean hands. Doctors considered themselves to be true gentlemen, so they always said or claimed to have clean hands. So imagine giving birth and helping somebody give birth, and then moving on to the next mother and helping that mother give birth. So that created a lot of transmission and a lot of unfortunate fatalities that could have been avoided. Now there are very strict guidelines as to hand washing and sanitation. You have the right to ask any doctor that is treating you to wash their hands before they treat you, even though I'm sure they have and their hands are clean, or even just using hand sanitizer. So your job is to do a little bit of research and figure out how soap works and why it's so effective. I did give a lot of information here, and you can use some of the information that I told you, but you are going to be doing a little bit of reading, watching another video to answer those questions. Thanks.